Hello, this is Shannon Gracie, professor at Maricosta College, and we are on section 5.6 of Robert Blitzer's book for Introductory and Intermediate Algebra for college students. Today we will be covering long division of polynomials and synthetic division. So here we go. Let's go ahead and warm up, and I'll do this one with you because I think a lot of us, it's been a while since we've used long division, and in order to understand polynomial long division, one needs to understand long division using numbers that we know. So here we go. If you take a look, we kind of do partial quotients. So we're looking at how many 56s are in 123, because there's 0 56s in 1 and in 12. All right, so here we go. We will put, I believe there are 2 56s in 123. So we put down here part of the quotient, and then 2 times 56 gives us a result of 112, and we're subtracting 112, and now we get our new part of our quotient. So we'll get the actual remainder first. So 3 minus 2 is 1, 2 minus 1 is 1. So we got a remainder of 11. We're bringing down 4, and now we have this new quotient, partial quotient of 114. So again, we're thinking, how many 56s are in 114? We know there will be 2 from above. 2 times 56 gives us 112. We are subtracting that from the 114. We get a result for our remainder of 2. And then we are bringing down this 5. Well, how many 56s are in 25? 0. Don't forget to put that place of 0. 0 times 56 is 0. So we're just really subtracting 0. And we end up getting a remainder of 25 this time. We now bring down our 6. So how many 56s are in 256? I believe there are 4. 4 times 56, 24, and we get 22. Oh, let me be consistent with the colors here. I'll use the red. So we ended up getting 224, and we are subtracting that. And our remainder will get 32. And finally, we'll bring down this last bit to divide. And we're seeing how many 56s are in 327. It turns out there are 5. 5 times 6 is 30. We get 28. Again, that should be in red, sorry. To be consistent, 280. And then when we subtract that, we get a remainder of 47. So let's talk about what we got here. We found out that 1, 2, 3, 4, 5, 6, 7 divided by 56 was equal to 22,045. Okay. And then our remainder was 47 out of 56. Now, with a mixed number, what's implied, this implies a result of 22,045 plus 47 out of 56. This is what, these are equivalent. This is what that means. And we need to know this because we're going to be having variables in there. All right, so let's talk about the parts of this problem. All right, so here we go. 56 is the good divisor. 1, 2, 3, 4, 5, 6, 7 is called the dividend. The result or part of the result, 22,045, is the quotient and then any leftover is the remainder. The remainder goes over the divisor, okay, like we did there. 47 was the remainder, right? And we wrote our end result as 47 over 56. Okay? That way we don't have to say 22,045 remainder 47. Okay? Okay, so here we go. Now, another warm-up, and I'll let you do this one on your own. This warm-up here is necessary for us to, be able to do the following. So pause the movie and give this one a shot. Okay, let's see how you did. So remember that this guy we can rewrite as 5x to the 5th divided by 2x squared minus 8x cubed divided by 2x squared, and then plus x squared divided by 2x squared. So this will give us 5 halves x to the 5 minus 2 minus 8 halves is 4, and we'll get x to the 3 minus 2, and then 1 half x to the 2 minus 2, which will yield a result of 5 halves x cubed minus 4x to the 1 plus 1 half x to the 0, which gives us 5 halves x cubed minus 4x plus 1 half times 1, because remember x to the 0 is 1. So we'll get 5 halves x cubed minus 4x plus 1 half. Or, again, you can write this as 5x cubed all over 2 minus 4x plus 1 half. Either one of these results is okay with me. Okay, so now we're going to learn some steps for dividing a polynomial by a binomial. Okay, so what we need to do is make sure it's set up correctly. So the first step, and often it's done for you, but the first step is to arrange the terms of both the dividend and the divisor in descending powers of the variable. Now, here we go. We're going to kind of skip back and forth. We'll fill in steps and do a problem sort of simultaneously. So you'll be flipping back and forth here. The second step is to divide the first term in the dividend by the first term in the divisor. The result is the first term of the quotient. Okay, so you have to be careful. One thing that isn't in here that we should probably write in, let's just kind of sneak it in here. When we're arranging the terms of both the dividend and divisor and descending powers of the variable, right? For the dividend portion of it, if any powers are missing, you write in 0 times the power, right? In 0 times x to the whatever's missing. I'll just put 0 times, I'll write it in words, 0 times x to the actually, I figured out a better way to say this. We'll say 0 times the missing term. Because 0 times anything is 0. So basically you're just lining it up so you don't get confused later when you're into the division. Okay, and this is only for if something is missing in the dividend. Okay, so let's take a look here. We're going to skip down to this first problem. All right. Now, we've got, so inside the house, we're going to have the dividend, which is x squared plus 7x plus 10. The divisor goes outside the house. I'm going to put parentheses around it, and you'll see why shortly. And notice that both the divisor and the dividend were already written in descending powers of x. All right, so now, here we go. If you need to do some side work, go ahead. All right, so this is our side work. So that first step says that you divide the first term in the dividend by the first term in the divisor. So our side work is just going to show that. We're not allowed to split the divisor, okay? We're not allowed to split the divisor. We're just doing this sort of as a means to an end. Okay, so the side work is we're doing the first term in the dividend, which is x squared, divided by the first term in the denominator, which is x. And what do we get when we do that? That's equal to x to the 2 minus 1, which is equal to x. Good so far? So, this is what we write up top. We put in an x here. Okay? Now, remember how before you put in the number and then you multiplied through? We're doing the same thing. What you have to remember is you have to distribute that x through the x plus 5. So x times x gives me x squared, and then plus x times 5 gives me plus 5x. But what we're going to be doing is subtracting this whole thing. Now, the common mistake that students make is they forget to distribute that minus through the second term. So here I've got x squared minus x gives me 0 x's, which is what I wanted. Okay, if you did it right, your first term will zero out. Then we get 7x minus 5x's gives me 2x's. Now, I have to bring down my next term. So that is the remainder from that work. And the next term, you bring it down with the sign, is plus 10. Now I've got a new problem I'm working. So my second bit of side work is the first term in this new dividend is 2x, and I'm dividing it by the x that is the first term in the divisor. And you see that gives me 2x to the 1 minus 1, which is 2x to the 0, which is just 2. So then I have to add 2. Then I distribute that through. 2 times x gives me 2 x's, which is what I wanted. I wanted the same thing because I'm going to be subtracting it. 2 times 5 gives me plus 10. And then I'm subtracting that whole binomial. And I'm going to see if there's a remainder. Well, I get 0 x's plus 0, which is just 0. So, what did I find out? I found out that x squared plus 7x plus 10 divided by x plus 5 is equal to x plus 2. That's my answer. How are we doing so far? Okay, so now just to let you know, another way to think about these types of problems, if you don't like the way the side work looked, you can go over here and you could say, okay, x times what number gives me x squared, because you want to match this. And so if you feel more confident doing it that way, you would have said, oh, x times x equals x squared, and you would have yielded your x that way. So it just depends on how you like going about it. That's going to be your preference. Okay? Alrighty, so here we go. Let's fill in, we went through a lot here. Let's fill in the rest of the steps. I got a little carried away here. All right, so here we go. Our third step was we multiplied. So multiply every term in the divisor by the first term in the quotient write the resulting product beneath the dividend with like terms lined up. Oops, sorry. Beneath the dividend with like terms lined up. Then subtract the product from the dividend. Step 5 was to bring down the next term in the original dividend and write it next to the remainder to form a new dividend. Use this new expression as the dividend and then repeat the process until the remainder can no longer be divided. This will occur when the degree of the remainder is less than the degree of the divisor. Okay, so let's take a look back at this problem and see what happened. So there, this part here, the 2x, right, was the, considered a remainder. Right? And this 2x plus 10, okay, the whole 2x plus 10, to find a different color, I'll do it in orange. This 2x plus 10 is was the new dividend they were talking about. Okay? And then, 0 is another remainder, but that we can't do anything more with that, so we were done. Okay, so now let's practice. Part B, I'll get you started. Inside the house, we've got 2y squared minus 13y plus 21, and outside the house we have y minus 3, and we're going to put that in parentheses so we don't forget to distribute. Now, if the side work stuff confused you, you can think about it this way. Y times what gives us 2y squared? Good, you would have y times 2y, that yields a result of 2y squared. If you don't like that, you have your side work, okay? And your first bit of side work was 2y squared divided by y equals 2 times y to the 2 minus 1, which is 2y. You see how we got that? Okay, now we have to distribute this 2y through this y minus 3. So we'll get 2y squared minus 6y, and we need to subtract that binomial. So the first term zeroes out, which was our whole evil plan. We want that to happen. Now be careful. We have negative 13y minus a minus 6. So that's going to turn into a positive 6. So we'll end up with a negative 7y. That's our remainder. We need to bring down the next term, which is plus 21. And then we do it all over again. So again, you can either think y times what equals negative 7y. Well, y times negative 7, right, is negative 7y, or you can do it via the side work, where you would have negative 7y divided by y is negative 7y to the 1 minus 1, which is negative 7y to the 0, which is negative 7 times 1, which is negative 7. So then, multiplying through, negative 7 times y is negative 7y. Negative 7 times negative 3 is positive 21. Now be careful, they're trying to sort of sucker you into something here. So here, the 7y's zero out. Oh, and actually they're not. The 21's will also zero out. So we will get a remainder here again of 0. So what we have found out is that 2y squared minus 13y plus 21 divided by the quantity y minus 3 is equal to 2y minus 7. And we're done. Okay. Next up, I will go ahead and let me give you a hint here. I don't want you to end up being too astray. Notice that we don't have an x to the 1 here. Okay? So in the house, we're going to need to have an x cubed plus 2x squared. Then we're going to say plus 0x minus 3. That'll keep everything lined up. And our divisor is x minus 2. So pause the movie and see if you can do this problem. And then check back and see how you did. Okay, let's see how you did. Again, I'll verbalize it and then we'll show the side work. Okay. So x times what equals x cubed? Good. You would have x times x squared equals x cubed. If you have issues with that, just do your side work. The first term of the dividend is x cubed divided by the first term of the divisor is x. That gives us x to the 3 minus 1, which is x squared. Distributing the x squared through the divisor, we will get x cubed minus 2x squared. We subtract this whole binomial, and we get a remainder of 2x squared minus a negative 2x squared gives us 4x squared. Good. And then we're going to bring down our plus 0x to keep everything lined up. Okay, so again, verbalizing x times what equals 4x squared. Well, it's positive, so I put a plus, and it'll be a 4x. If that doesn't work for you, do more side work. We have our leading term here, 4x squared, divided by x gives us 4x times x to the 2 minus 1, which is 4x. Distributing, we get 4x squared minus 8x's. And we are going to subtract this binomial. The 4x squared 0 out as we wanted, and then minus a minus 8x gives us a positive 8x. And then we need to bring down our next term, which is minus 3. And then either you think to yourself, x times what equals 8x's? That would be plus 8. Or you come over here and work it out. 8x divided by x equals 8x to the 1 minus 1, which equals 8x to the 0, which is 8 times 1, which is 8. So, long story short, we end up with 8x, and then 8 times negative 2 is minus 16. We're subtracting the whole binomial. The 8x is 0 out. Negative 3 minus a minus 16 is positive 13. So this time we have a remainder. Okay? So we have a remainder. Okay? So here we go. What we found out was that x cubed plus 2x squared minus 3 divided by x minus 2 equals x squared plus 4x's plus 8 plus the remainder 13 over the divisor x minus 2. And then we're all done. How'd you do on that one? Hang in there. A lot of students find this, to be difficult. You'll catch on. It'll be fine, I promise. Okay. All right, let's see how this next one. Okay, we have to be a bit careful here. Notice that I don't think there's any terms missing, but they're not in order. Okay, so when we're putting everything in our box, we need to write them in descending order. So there's y to the fourth plus 8y cubed, and then we have plus 24y squared plus 32y plus 16, and that's being divided by y plus 2. Okay, so again, if you're doing some side work, right, we would take the first term in the dividend, y to the fourth, and divide it by the first term in the denominator. That would give us y to the 4 minus 1, which is y cubed, or you can think of it as y times y cubed equals y to the fourth. Distributing, we get y to the fourth plus 2y cubed. We subtract, and this yields a result of 8 minus 2y cubed is 6y cubed. Bringing down our next term, we have plus 24y squared. So our new dividend to work with are these two terms here. So if we're doing the side work, we would have our next one, we would have 6y cubed divided by y would be 6y to the 3 minus 1, which is 6y squared. So we would put positive 6y squared. That yields a result of 6y cubed plus 12y squared. And we'll be subtracting that binomial. We get a result of the 6y cubed zero out, and 24y squared minus 12y squared is positive 12y squared. And then we'll need to bring down a positive 32y. And then again, more if you do the side work, 12y squared divided by y equals 12y to the 2 minus 1, which is 12y. That gives us our next term here. And 12y times y is 12y squared. 12y times positive 2 is plus 24y. Subtract the binomial. The y squared zero out. We will end up with, 8 y's. And then we'll be bringing down our next term of plus 16. Our last bit of side work. 8y divided by y is just going to be 8. So then I put that over here. 8 times y is 8y. 8 times positive 2 is positive 16. And then we're going to subtract, and we will end up again getting a 0 remainder. So what we found out, I think I have room next to our problem here. So what we found out is that this division problem equals y cubed plus 6y squared plus 12y plus 8. All right, so here we go. Now, before we start this next section, or not section, the next part of this section, which is synthetic division, I just need to caution you. Polynomial long division always works. Right? So if you're having trouble learning this and you're kind of torn between learning one or the other, learn polynomial long division. Synthetic division only works if your divisor is in a certain form. Okay? So, here we go. Dividing polynomials using synthetic division. We can use synthetic division to divide polynomials if the divisor is of the form x minus c. This method provides a quotient more quickly than long division. Okay, so here we go. Let's practice a little. All right, if I had x minus 5, right? What is c? C equals, good, it already has a minus, so c would just be 5. What if I had x plus 1? This is the same as x minus negative 1. So c would be negative 1. The minus is in the formula, so if you have x plus something, you got to flip the sign for your c. Now, if you have a coefficient other than 1 to your x, or if x is raised to something other than the 1 power, you cannot use synthetic division. Okay, so here are the steps. Arrange the polynomials in descending powers with a 0 coefficient for any missing term, just like before. Write C for the divisor, x minus c. To the right, write the coefficients only of the dividend. I'll just do all the steps since I got carried away last time, and then we'll go through and do an example. Write the leading coefficient of the dividend on the bottom row. Multiply c times the value just written on the bottom, row, and you're going to write the result or the product in the next column, but in the second row. Add the values in this new column, writing the sum in the bottom row. And then you just repeat this series of multiplications and additions until all columns are filled in. Okay, so then use the numbers in the last row to write the quotient plus the remainder above the divisor. The degree of the first term of the quotient will be 1 less than the degree of the first term of the dividend, because we were dividing by x to the 1 minus some constant, so therefore it will just reduce the powers of x by 1. The final value in the row is the remainder. Okay, so I know that probably doesn't seem completely clear to you, so let's check it out. First of all, the divisor is x minus 1. So do you see that C is 1 because we already have a minus there? So C equals 1. Right? So here we go. You put in your C and you write a little box like this. Now you write the coefficients. So do you see this is 1x squared plus 1x minus 2? So we're going to put a 1, and then a negative 2. We're going to leave a space for a second row. Then this one drops down here. Now we do start the multiplications and the additions. So here we go. We're going to do 1 times 1 equals 1, and we're going to write it right here. So 1 times 1 equals 1. Then we add. And when we add 1 plus 1, we get 2. I'm going to put a little line right here. You put a little line where the constant was. That's going to be your remainder. So again, we do the multiplication. 2 times 1 is 2. 2 times 1 is 2. Negative 2 plus 2 is 0. So there's a 0 remainder. So what we found out is that x squared plus x minus 2 divided by x minus 1 equals, right? So here, this gave us 1x to the 1 because we add a degree of 2 here. So 1x to the 1 plus 2. Well, 1x to the 1 is just x, and then plus 2. That is our end result. Okay? Okay. Next step, part B. We will have to rewrite this. So we have 1x to the 4th minus 6x cubed plus 1x squared minus 6x, and then you got to do plus 0 because the constant term is missing. And then I'm going to write divided by x plus 6. Okay, so x plus 6 is the same as x minus negative 6. So C equals negative 6. Whatever comes after the minus on that divisor is your C. All right, so we'll come over here and we'll write our C, and then we're going to do our coefficients. 1, negative 6, 1, negative 6, and then 0. Leave space for our second column. Figure out where our remainder is going to go. This 1 comes immediately down. And then again, we do the 1 times negative 6, and we're going to put the result there. And that's negative 6. Negative 6 plus negative 6 is negative 12. Negative 12 times negative 6 is going to be, what, 72? And then 1 plus 72 is 73. 73 times negative 6 gives us, I think, negative 438. And then adding, we will get negative 444. And then when we multiply negative 444 times negative 6, we will get positive 2664. When we add that to 0, we get 2664. So again, here we go. This is 1x to the, we go down 1. So our degree of this polynomial was 4. This one's going to be 3. So n minus 12x squared plus 73x's minus 444 plus 2664 over the divisor, which was x plus 6. So I'll just write it up here. We ended up with x cubed minus 12x squared plus 73x's minus 444 plus 2664 over x plus 6. And that was our answer. Okay, so C and D, why don't you give them a try. Just a hint, there are a lot of missing terms in C. Okay, part C. So pause the movie and see how you do with these. Time to check your work. Here we go. All right, so x to the 7th minus 28 is equivalent to, so I'm do it in our regular colors. So x to the 7th minus 128 is 1x to the 7th plus 0x to the 6th plus 0x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x minus 128. And then we have the x minus 2, that gives us c equals 2, because our minus is already in it, so that's our c. Okay, so we've got our box here, and then we're going to have a 1, and then 1, 2, 3, 4, 5, 6 zeros. And then the negative 128. And that's where the remainder will go. And we bring this one down and we start our series of multiplications and additions. So 1 times 2 is 2, and added. And then 2 times 2 is 4. When we add, we get 4. 4 times 2 is 8. Add that to get 8. 8 times 2 is 16. We add to get 16. 16 times 2 is 32. When we add, we get 32. 32 times 2 is 64. And when we add, we get 64. And 64 times 2 is positive 128. And when we add, we get 0. So again, this means that we add x to the 7th, a degree of 7. When we decrease that by 1, we get 1x to the 6th plus 2x to the 5th plus 4x to the 4th plus 8x to the 3rd plus 16x squared plus 32x plus 64. So the resulting quotient is x to the 6th plus 2x to the 5th plus 4x to the 4th plus 8x cubed plus 16x squared plus 32x's plus 64. Okay, so let's see how D went. We already have these written in descending order. Do you guys see that C is going to be 2? Because it's already got a minus. So here we go. We've got our 2 in the box. 1 y to the 5th. Negative 2. Negative 1. 3. Negative 1. And positive 1. Bringing down our 1 here. Oops. So 1 times 2 is 2. Negative 2 plus 2 is 0. 0 times 2 is 0. Negative 1 plus 0 is negative 1. Negative 1 times 2 is negative 2. 3 plus negative 2 is positive 1. 1 times 2 is positive 2. Negative 1 plus 2 will give us a positive 1. 1 times 2 is 2. And 1 plus 2 gives us 3. So, again, we had a degree of 5, so this means we get 1x to the 4th plus 0x cubed minus 1x squared plus 1x plus 1 plus 3 over our divisor of, oh, look what I did. Bad teacher. Actually, you know what? We did not have x's, did we? We had y's. So all of these little x's we need to change to y's. Sorry about that. So that'd be 1y to the 4th minus, or plus 0y cubed minus 1y squared plus 1y plus 1. And that'd be 3 over y minus 2. So writing it up here, we have y to the 4th. The 0y cubed zeroes out. So minus y squared plus y plus 1 plus 3 over y minus 2. Okay, so now there's an application just to kind of pull it all together here. So here's the scenario. You just signed a contract for a new job. The salary for the first year is $30,000, and there is to be a % increase in your salary each year. The algebraic expression 30,000 times x to the n minus 30,000 divided by the quantity x minus 1 describes your total salary over n years, where x is the sum of 1 and the yearly % increase expressed as a decimal. Use the given expression and write a quotient of polynomials that describes your total salary over 4 years. So what that means, okay, over 4 years means that n will be 4. So let's take a look at what we would get. So we would get 30,000 x to the 4th minus 30,000 all over x minus 1. And that's the result for the first one. Okay, and then next up, simplify that expression by performing the division. So let's go ahead. Our C would be 1. I'll use the synthetic division. We're going to have 30,000. Now there's no cubic term. There's no squared term. There's no x to the 1 term. And then we'll have a minus 30,000 here. And bringing the 30,000 down, multiplying, we get 30,000. So 0 plus 30,000 is 30,000. And then multiplying, we'll get 30,000. 0 plus 30,000 is 30,000. Multiplying, we get 30,000. 0 plus 30,000 is 30,000, and then multiplying, we get 30,000, and negative 30,000 plus 30,000 is 0. So what we found is that $30,000 to the 4th minus 30,000 divided by x minus 1 equals Now remember, the degree will go down by 1, so we'll get 30,000 x cubed will be our first term, plus 30,000 x squared, plus 30,000 x, plus 30,000. And there was no remainder. So this is what we found. Okay, now what we're going to do is we're going to explore and make sure that these two expressions are equivalent. Okay, so suppose you are to receive an increase of 8% per year. So that means x is the sum of 1 and 0.08, which is 1.08. So that's what we'll be substituting for x in the expression in part A, as well as the simplified expression in part B. And we're to evaluate each expression, you'll need a calculator for this, and we need to find out our total salary over the 4-year period. Okay, so here we go. So at x equals 1.08, we had 30,000 times x cubed. So I'm doing the one we just did in part B. And then plus 30,000 times x squared plus 30,000 times x, and then plus 30,000. And you will find that that is equivalent to approximately $135,183. Okay, and now comparing the other one, we would have 30,000, this is the original expression, times 1.08 to the 4th, minus 30,000 over 1.08 minus 1, and this one you get approximately 40,815 minus 30,000 over 0.08, and that gives you a result of 135,000, or approximately 135,183. All right? So they match, and that's what the point of this problem was. Okay, so that wraps up 5.6. We've got one more section of Chapter 5, and I hope you have a fabulous day. Bye.